Start again. So this is the second part of our 50 practice problems marathon. So we had one at 9 a.m. part 1, and now we are having part 2. So so we are since we are running out of time, we are going slow. We have to postpone the 10:30 meeting. So actually 10:30 was scheduled to be part 3, but we will postpone it to evening because another class of Ankit sir is going to be there from 11 a.m. Okay, so right now we have 5 p.m. At 5 p.m. we have part 4, and at 5:45 we have part 5. So we are scheduling part 3 at 4 p.m. Okay, so this will be the new schedule. So right now we are doing part 2, and part 3, part 4, part 5 will be 4, 5 and 5:45 p.m. Okay, so we'll do 10 questions in this lecture, and then we'll do remaining 30 problems after 4 p.m. today. Okay, let's start. So Atharv, we have a playlist. Okay, so all of these videos are present in a playlist. Okay, and lectures are not numbered for the initial lectures. I'll get them numbered today. So yesterday there was a query that the contest submissions are not visible, so I resolved that. You can see all the solutions which the participants have submitted for contest 1 and 2. For contest 1 and 2 you can see the submissions now. We are left with one discussion session on practice test 3. So I'll open the submissions after that discussion. So tomorrow I'll open the submissions for contest 3 as well. Okay, for now you can see all the submissions for contest 1 and 2. Okay, and we have a new query now that, okay, so I'll share the playlist link. So I have to share the playlist link, and we have to number the initial lectures. So initial 15 lectures are not numbered, but they are in the order in playlist. Okay, so you can see the playlist and you can see all the lectures there. Okay, cool. So let's start. So those who have joined this meeting for the first time, so this is the Telegram group. Okay, we have created a Telegram group. You can just copy this link in your address bar of your browser, and you will get access to the Telegram group. Okay, so here we will post the updates of lectures and contest so that you don't miss out anything. So I'll post it at least 20 or 24 hours before the lecture and the contest. Okay, so that you don't miss anything. So please join this Telegram group as well. So I see that many people have already joined, and actually you can ask doubts in this group as well. So daily we will come up with some timing. I'll post that in the group only. Where in that slot you can post your doubts as well. Okay, so we'll keep an interactive session in Telegram group also. So yeah, let's begin. Okay, so we were on this question. So this question is not related to OOPS, but it is related to precedence and pointers. So this is very important concept coming to placements. That's why I am emphasizing on this a lot. So we left this problem in the last 50 practice problems in C++ basics. So that's why we are doing 2 problems here, and then we'll continue with OOPS. So what do you think will be the output here? So you can, whenever you have these type of question, you can quickly Google the precedence table for C++. Okay, C++ precedence table. Okay, then on Wikipedia or c++.com, c++reference.com, which is the official website, you can see the precedence table. Okay, and then you can solve the problem. Okay, so for these type of things you need precedence rules. Okay, so I'll look into them and I'll tell you the precedence. First you try to solve this problem, and then we'll look at the answer. So write the answer for all the 3 Couts in the chat box. Take your time, it is a big question. Okay, take your time, see the precedence and what will be the output. Okay, so there is no error in this code. Okay, there is no error in this code. First hint is that. So I'll let you know the output of first and second cout. Third is a bit tricky, so I'll give you more time for the third cout. So I'll tell you how the first and second will work, so that you get some idea at least. Okay, so first thing, the precedence of dereferencing, and we have pre-increment here only. Okay, we only have pre-increment here. So the precedence of dereferencing and pre-increment is same, actually same. So what will happen? You have to see the associativity. So the associativity of both of them is right to left. Okay. So what will this expression mean? So so here we have four operators: plus plus dereference, plus plus dereference. Okay. Precedence of all the four operators is same, and the associativity is right to left. So firstly, asterisk q will be evaluated. So this statement is indeed is actually equivalent to asterisk q, then increment, then asterisk, then increment. Okay. So this is what happens. This statement is equivalent to this statement due to associativity and precedence. I hope you understood this thing. Now it is very easy question if you know pointers. So the array A will be 1, 2, 3, 4, 5, 6, 7. So if you don't understand pointers by arithmetic like plus minus 1, then take addresses. So when you take addresses, everything will be easy. Okay. So let's say this is at memory location 100, 104, 108, 112, 116, 120 and 124. Okay. So A is basically memory location pointing to 100. So this is an array. And now we have P. So P is in pointer to an array. So P is an array of pointers to integers. So P is an array of size 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So P points to integers. P is an array of pointers to integers. So first contains the address of a plus 1, which is 104. Second contains the address of a plus 3. This is a plus 1, this is a plus 2, this is a plus 3. Okay, this is a plus 4, a plus 5, a plus 6. So a plus 3 is 12, 112. A is 100, a plus 5 is 120, and a plus 4 is 116. Okay, just take addresses, everything will look easy. Okay, and this array will also be present in memory. Okay, memory locations. So let's say the size of pointer is also 4 bytes. Okay, so let's say these are present in memory location 200, 204, 208, 212, 216. Okay. Now there is a pointer q, which is pointer to an pointer. Okay, and we are giving the address of p to it. So q will store 200, and let's say q is present in memory location 300. So just draw this map and everything will look clear. Okay, everything will be easier. So we have a, p and q ready. We have their addresses. So this is a plus 1 and so on. This is p, p plus 1, p plus 2, p plus 3, p plus 4, and this is q, right? So what happens now? So this statement is first you have to dereference q. So you dereference q, you go here. You go at the memory location 200. Then you increment the contents of this memory location. So when you try to increment it, it will be incremented by 4 bytes. Okay, due to pointer arithmetic. So this was this had 108, this had 104. Okay, a plus 1, this had 104, but it will get incremented to 108 due to this increment, right? Then we dereference it. So that means we go at this location. So this now points to this location. So we go at this location and we increment this. So this will get incremented to 4. Okay, so this is what happens in this operation. So before that we had to print some values. This was easy. Asterisk a was 1. Okay, because a is equivalent to 100 and asterisk a is equivalent to 1. And beforewards we had p contained 104. So asterisk p was here 104 location, and asterisk p was dereferencing 104, which was 2. Okay, and similarly asterisk q was again 2. Okay, so this statement was easy. I hope you get that by your own. So what this expression means is, I have told you, you have to do it in this way, right? So now you can print the values. What is asterisk a? Dereferencing the value present at a is equivalent to 100, so 1. Okay, what is asterisk p? What is p? 200. What is asterisk p? Dereference 108. So what is asterisk p? 108. And what is asterisk p? Dereference the memory location 108, which is 4. Okay, similarly what is asterisk q? So we should have one more dereference here. Okay, we should have one more dereference here, right? So q is 300, asterisk q is 200, q is 300, asterisk q is 200, asterisk q is 108. So again 4 will be printed. Okay, so I hope you got the output of these two statements. Now in the similar fashion, try to do these two operations, and what will be the output? Print the output of third cout. Just write in the chat box. So guys, you can take more time if you want. Just write in the chat box if you want more time, or I'll do the solution. So Swapnil, Q means 200 and asterisk Q means what is present at 200, so which is 108. No, asterisk Q doesn't mean that we are at memory location, asterisk Q means that we are at memory location 200, right? So when we increment, so Q will now point to 204, no. When we increment asterisk Q, the contents of whatever present at Q will be incremented. So the contents of 200, which is 104, will be incremented. Okay, so there is a difference. So I have written all the values correct here. Okay, so you can see this here. What happens is Q is 200, okay, and Q is 300. Asterisk Q is 108. Asterisk Q means what is present at this location, 108. Okay, so asterisk Q is equal to P. That's why P equal to and Q. Okay, so yeah, this is how it happens. So I hope you get this. So actually there we don't need 3 asterisks, right? We don't need 3 asterisks. You know why? We don't need 3 asterisks. The 2 is fine. So I told it wrong here. Why? Because Q is 200. Q is 200. So actually P and Q are of same type. P and Q are of same type. Both are pointer to pointer. That's why they both need 2 asterisks only. So Q contains 200 and P also contains 200. Okay, so they both are of same type. So actually P and Q are of same type, and P is also pointer to pointer, Q is also pointer to pointer. So when you write asterisk Q, you will be dereferencing this 200 and you will be at 108. So you need only one more asterisk to dereference what is present at 108, which is 4. Okay, so only 2 asterisks are required. Asterisk Q is not 200, asterisk Q is 108. Asterisk Q is not 200, guys. Q is 200, P is 200, A is 100. Here what happens? A is 100, but asterisk A is 1. Okay, so pointer holds an address. Asterisk Q is not 200. This is the memory location Q, not the pointer. Q is not a pointer pointing to this location. Q is this location, and asterisk Q is this location, 108. P and Q are of same type. Q doesn't point. Okay, so I hope you got this now. So if you want your type of functionality, you would have written like this. If we have written like this, int asterisk 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 Q equals and P, then P would be an pointer. Then Q will be an pointer pointing to this location. Okay, I hope you got it now. So Q is equal to 200, but asterisk Q is equal to 108. So we did it right. So okay, so I guess we should solve the question now. Mohit, that's an assumption. That's an assumption. Q also will hold some memory. Q is a pointer. Q will hold some memory. So the address of Q is 300. This is right. Address of Q is 300. Let's say Q is a pointer which is present at memory location 300. It points to the first element of this array. P also is a pointer which points to the first element of this array. We know that the name of the main name of the array is equivalent to a pointer pointing to the first element. Okay, so the name of this array, which is P, contains the address 200, which is the first memory location. Okay, so if this array is present at 200, 204 and so on, if this array is present at 200, 204 and so on, then P contains the address of the first memory location. So P equals 200. That's why asterisk P equals the whatever is contained inside this, which is 108, which is again in memory location. So when you write asterisk P, you dereference 108, which is 4. Okay, so we have got some correct answers. So first one to solve was HM Classic. So whoever you are, very good. And Ashwini also, yeah. So 152 should be correct. So let's see how. So I'll remove some statements so that it can be. Okay. So right now this is the scenario, right? So let's resolve the statement first. So what this statement means, we know the precedence. It is so the precedence is same and associativity is right to left. So this statement is equivalent to plus 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 asterisk P. Okay, so first you have to dereference P. So you go at this memory location 108. P is equal to 108, asterisk P is equal to 4. Right? So you dereference this and you are here in this memory location and you increment it 2 times. So this 4 will become 6. Okay. Okay, sorry. So I did a mistake here. Okay, sorry. So we didn't dereference P. So P, I made a mistake. P is 200. Okay. P is this memory location 200. So the name of the array is equivalent to the address of the pointer to the first location, right? So P is an pointer which contains 200. Okay. And asterisk P means that you dereference this location. So you are at 200. So you can think of it this way. So this is an array. This is an array of 5 elements, and this array starts at memory location 200. So the name of the array, let's make it a different pointer. And it contains 200, and it is stored at memory location 400. Let's say. So this name P is stored at memory location 400, and it contains the address of this the address of the first member of this array, which is 200. Okay. So when you dereference P, you are at this location. This is same as what we did in the previous problem. Okay, previous statement. So asterisk P is at, you are here 108, and you are incrementing it 2 times. So So the address of A plus 4 will be present here now, 116. Okay. What is asterisk P? It is 108. What is P? It is 200. Q is also 200, P is also 200. P and Q are of same type. Okay. So asterisk P is now was 108, but you incremented it 2 times. So it became 116. So now it will point to this memory location. Okay. Okay, so now it will point to this memory location. So what were the values present here? I don't know. Okay. So these were the contents. So yeah, this will happen. This will happen with the first statement. This will get incremented to 116. Now let's see the second statement. So I am writing it here only. So first is this, then this, then dereferencing, then increment. Okay. First let's increment Q. Okay. So Q is equal to 200. Q is equal to 200. So Q, when you increment Q, Q will become 204. q is equal to 200. When you increment q, it will increment to 204 due to pointer arithmetic. Now you increment it again, it will become 208. Okay, now you dereference it, so you are at this location. Okay, and then you increment this location, so 100 will get incremented to 104. Okay, I hope you got this. So this question had been somewhat difficult without the addresses, right? So I hope everything is clear right now. Now let's see, what is asterisk A? Okay, what is asterisk A? It is 1, because A is 100, so asterisk A is 1. What is asterisk P? What is P? 200. What is asterisk P? 116. What is asterisk P? 5. Right? What is asterisk Q? What is Q? 208. What is asterisk Q? 104. What is asterisk Q? 2. So just write in the chat box if you got this, the output. Guys, did you get this question? Asterisk Q in third output is 2. Yeah. Okay, let's move forward. So you can watch this video again if you have some doubts. Yeah, okay, so then it will get clear. Okay, this is not rocket science. This is easy. Okay, you just have to take care of addresses. Okay, let's move to another problem of pointers only. Okay, so that this time we are handling strings as well as pointers, character pointers or strings. So let's see you can solve this or not. So this is the this problem was also left in C++ basic, so we are doing this here. Now from the next problem we'll start oops problems again. So there is just one thing which I want to tell you in this problem. So when you have a character pointer, let's say P, and it holds some address, and at this address we have some character array. So let's say A, B, C. Okay. Okay. So when you do this, cout asterisk P, what happens is the entire string will be printed until the null character arrives. Okay, so every character array in C++ automatically appends a null character at the end. Okay, when you initialize it like this, automatically a null character is added at the end. This is from the C concepts. Okay, So when you write cout asterisk p, it will keep printing this memory location until the null character arrives. So when you write cout asterisk p, ABC will be printed. Okay, so this is the one thing I wanted to tell you. Now you can try doing this question. So what will be the output of first cout? Just write this first. Okay guys, so most of you have got it right. So is will be printed. So why? Let's see. So we'll do in the same way. Let's say so P is like this. Okay, P is an array of character pointers. So I'm drawing P. Okay. So P is an array of character pointers. So let's say this is P. It contains 4 character pointers. 1, 2, 3, 4. So P is at some memory location. Pointer holds 4 bytes. And these are character pointers. They points to characters. Character arrays basically. These are character arrays. Okay. So this points to hello. The starting location of this. Okay, this points to this. And this pointer points to a character array which is. Okay, and this points to there. So sorry, the starting location. Okay, so this is how P looks like. Okay, they can all be on some memory locations. You can assume some and write their starting addresses here. Okay, so if this starts at memory location 10, 20, 30, 40, 30, 10, 11, 12 and so on. So 10 will be present in P. Okay, so here 10 will be present, here 20, here 30 and here 40. And P, which is the name of the address, is equivalent to a pointer. So P contains 100. Let's say it is at memory location 200. Okay, so p is equal to 100 and asterisk p is equal to 10. Okay, okay, right. Now, and q is another array. Okay, q is another array which points to pointers to characters. Okay, so it contains p plus 3. This is p plus 1, p plus 2, p plus 3. Okay, so 112, p plus 2 which is 108, p plus 1 which is 104, and p which is 100. This is q plus 1 plus 2 plus 3. Let's say this is at memory location 200, 204, 208, 212. So this is important. Character can take 1 byte, but the pointers to character or pointer to integer, all the pointer have the same size. So in the last problem we assumed that the pointer is of 4 bytes. So in this problem also we assumed that the pointer is of 4 bytes. Okay, so the pointer to any data type is of same size. So q, let's say, is so no, this cannot be memory location 200. Let's say this is memory location 2000. Okay, let's say q is at memory location 3000 and it contains 200. Okay, so this is how it looks. Q is equal to 200 basically, and asterisk q is equal to 112. Okay, and now we have a pointer to pointer to pointer. So r is at memory location 300 and is equal to q. Okay, r is equal to q, so r will contain 200. Since q is equal to 200, r is equal to 200, so that's why. So this is the entire scene. Now let's solve the problem. Okay, so what is the first statement? We already know the precedence. So it is like having a star and plus plus r. Okay, this is how it looks like. This is how it looks like. So first we have to increment the value of r. So when we increment the value of r, it will get incremented to 204 due to pointer arithmetic. Right? Now we dereference it and then dereference it. So first dereference will get to this location, which is 108. Okay. Second dereference, so what is the contents of 108, which is 30. So we'll go to the 30th location. So first dereference will get us to this location, which is 108, and at second dereference at 108 we dereference it, so we go to this location, which is and \0. So when you try to print this location, you will get is. I've told you this before. Okay, so the output of this particular statement will be is. So what will be the output of this statement? Try to do this. I am giving you a hint. I am solving the precedence rules for you. So this statement is equivalent to star minus minus star plus plus r plus 2. So this statement is equivalent to this because the precedence of addition is last. Okay, so this statement basically will be equivalent to this. So what will be the output? Okay, so some of you have got the right answer. So LLO is correct. So what will happen here? So what is plus plus R? Plus plus R is incrementing R. Okay, so R is 204, it will now contain 208. Simple. Now we dereference it. So we will add memory location 104. Okay, so we are at memory location 104. Now we, okay, so now we are at this location. Now we decrement it. Okay, so now we decrement it. So now asterisk R, which was pointing to q plus 2, will get decremented. Okay, so this now will contain 100. This now will contain 100, right, due to this decrement. Now we are dereferencing 100. So 100 we have 10, at 100 we have 10, and we are dereferencing it. So we are at hello. Okay, we are at hello. Now we are trying to print this plus 2. So this is memory location 10. So plus 2 means memory location 12. Okay, and we are trying to print from here. So LLO will be printed. So we have a comma also. So right. So LLO will be printed. Okay. Write the output of third cout. So I will give you a hint for this. P of 1 is equivalent to asterisk P plus 1. P of 1 is equivalent to asterisk P plus 1, right? So this asterisk is here, right? So when you write P, it is asterisk P, okay? And P of 0 is asterisk P. So P of 1 is whatever P is pointing to, you increment 1 to it and then dereference it. Okay, so it is like that. So what is R minus 2? R minus 2 is 200, right? Then you dereference it, then you again dereference it, and then you have a plus 1. Yeah, so AY is correct. So what will happen? So just remember this statement and everything will be correct. So asterisk P, so what is P of 0? When P is a pointer or pointer to an integer array. So what is P of 0? Asterisk P, right? What is P of 1? Asterisk P plus 1. So what will be P of minus 2? Asterisk P minus 2, right? So here, what is R minus 2? It is asterisk R minus 2. What is R? It is 208. What is R minus 2? It is 200. So R minus 2 is equal to 200. Okay, we are not decrementing anything, we are just doing some operations. So R minus 2 is 200 and R of minus 2 is dereferencing this. So we dereference whatever is present at 200. So we'll be at 112, which is 40. Now we again dereference it. So this implicitly contains a dereferencing and we are again dereferencing it. So we'll go at memory location 40. Okay, so here so we'll get to this memory location JY and we are trying to do plus 1. So if this is at 40, we will go to 41 and we are trying to print after this. So AY will be printed. Okay, this was easy. So just see the output of last cout. So what thing you want to repeat, Shubodh? Just tell me. The entire thing we cannot do. You have to watch the lecture again. If you have some specific doubt, then you can tell me. Okay, so now yeah, Swapnil, you are correct with the correct explanation. So the output will be HIS is, so what is R minus 1? It is asterisk R minus 1. Okay, so what is R minus 1? 204, and when you dereference 204, you are at 108. So asterisk R minus 1 is 108. Then you have again minus 1, so this is like asterisk, so when so you dereference 108 and you do minus 1, so 108 contains, okay, so yeah, asterisk R minus 1 is 108, and you have again 1 minus 1, so it will be 108 minus 1 asterisk. Okay, so this is like 2D array. Okay, so what is 108 minus 1? It is 104, right? Yeah, it is 104. So asterisk 104 is this memory location 20, and you are trying to do plus 1, so you will point to 200 to 21 basically, and you are printing it, so HIS will be printed. So I think now character pointers and this concept is clear, so we don't require any more questions in this now. We are done with pointers and character pointers and dereferencing stuff, right? Okay, let's look at some OOPS MCQs. What members of the base are never accessible to the child? This is again an easy question if you have watched the lectures. Why we have defined the protected members? What are private, protected and public? So yeah, A is correct. It is very easy question. So protected members are accessible to the child. Okay, when you derive a class, protected members are accessible, protected and public are accessible. Private members are not accessible to the child, so they cannot be used outside the class as well as they cannot be inherited, right? So yeah. Okay, let's do one more problem. So we have done this problem before also, so let's see that you remember the concept or not. Srinidhi, I'll share the link. Okay, we'll be doing 1 or 2 problems and then I'll tell you the link. Okay, I can write the link in the chat box as well. Just a second. Okay, so the question is which of the following operators can be overloaded? Okay. So I have posted the Telegram link, guys. So whoever was asking, I have posted the Telegram link. So guys, didn't you see the lectures? You're giving different answers. So 4 operators cannot be overloaded, actually 5. So scope resolution cannot be overloaded, member selection operator cannot be overloaded, member selection through pointer cannot be overloaded, and size of operator cannot be overloaded. Okay, all type of assignments can be overloaded. We have seen this question before. Okay, just watch the overloading video again. So this question should be correct. Okay, so this can be asked. Okay, let's look at the last problem for this lecture, then we'll continue at 4 p.m. okay. A class is tagged abstract if it has, I've repeated this, डाला है भाई मैंने. So very easy question, guys. A class is an abstract class if it contains at least one pure virtual function. Okay. So if it contains at least one pure virtual function, then it will be called abstract class. You don't have abstract keyword here. So in Java the concepts are different, but in C++, if you define at least one pure virtual class method in a class, then you cannot create objects of that class. That class will be abstract, and all the class which inherit this particular class should implement the pure virtual methods, right? Okay, so we'll see the problems at 4 p.m. We have many problems left in object-oriented programming now. So okay, we'll take a break for now. If you're watching me for the first time, I am Bansal. I got All India second rank in GATE Computer Science 2019 and All India 39th rank in ECM ICPC 2019. And I'll be teaching competitive programming, C++, data structures and algorithms on this YouTube channel as well as on Unacademy. So there are various batches going on. We have already seen Everest 2.0 yesterday started. It has 3 tracks: C++, Java and Python. Okay, so every problem will be solved in each of the 3 languages. You can watch whatever video you like. You have not missed out anything in the Everest right now. Okay, so you can go and see the curriculum for Everest. And so we have already discussed the curriculum in the beginning of this video. And if you want to take the subscription, you can use my code JCP to get 10% off. Okay, this is my code, referral code. Okay, so follow me on Unacademy as well, so that you don't miss the special classes. Also the telegram link I have posted, it is t.me/uncode CP. Okay, you can just search Uncode CP on Telegram to join the group, right? So we'll post the updates on this group from now on. So let's meet at 4 p.m. Okay, bye.